Good morning. So in last classes, uh, online classes, and even in the offline classes, we have just I have just completed the basic parts for you. That means for first few students. So till now we just saw what are the important parts. I mean, what are the important basic you require to understand the chemistry. I have just completed those parts. Some more parts are left, but for today's class, what I thought is let us start or let us start some problems. I mean, the basic problems. Those are not syllabus problems. I mean, the basic problem: how to calculate the neutrons, number of neutrons present in elements are in different atoms. Likewise, molecular formula, how to calculate the molecular mass, right? So we will just see the very basic, that means how to calculate the number of neutrons, right? So neutron one we can calculate before going to the directly into the neutron. So you people might have saw this type of, I mean, structures, right? So at the base there is something, there is a number. At the top there is a one number. What are these, right? First we will discuss these things, and then later we will calculate number of neutrons. To calculate the number of neutrons, we have one very easiest formula. So according to that, we will see, right? So by taking some examples, right? So this number is called a mass number, or right, and this mass number is denoted by letter A, right? So I have skipped some part of these. Just I'm trying you to explain what is mass number. I mean, mass number is nothing but the number of protons and the neutrons is nothing but, I mean, the number of proton and neutron present in the nucleus is nothing but the mass number, right? And this number is nothing but atomic number, right? This number, I mean, whenever there is the number present at the base, I mean at the base of an element, that is nothing but the atomic number, and it is denoted by a letter called Z, right? Very important. So the mass number, okay, you don't go for the definition of mass number and all. We will see later during the syllabus. But for now extent, you just understand the number which is present at the base of an element is called as atomic number, and the number which is present at the top of an element is called as mass number, and the mass number is denoted by a letter called A, and the Z, I mean the atomic number is denoted by a letter called Z, right? So here this example one we can write by taking this, see, A Z, that means A is nothing but what? Mass number. You can take this as a good example, right? So whenever there is a upper letter is always called a mass number, right? And which is denoted by what? Already we saw now, A. And there is a one more number which is present at the base of an element is called as, I mean, is nothing but atomic number, and which is denoted by Z. You can remember this part like this. That means X is nothing but any element you can take, and A is nothing but mass number. Always the upper number will be the mass number, and the six, I mean the base, I mean whenever the lower part of the element, I mean the lower number which is present in the element is nothing but the atomic number. So after knowing this, one we can directly go to calculate the number of neutrons present in the different elements like this, right? So we will see first the formula of this, right? So once if we know the formula, then one we can very easily calculate the number of neutrons present in the given species. N is equal to A minus Z. This is the formula, and this is very important for 1 mark. In your main exam in Pu1, they may ask to calculate the number of neutrons present in the following species. I mean, they will give some species. There you need to find out what is A value and Z value, right? So such examples we will solve now. Number one, where see here I will elaborate this formula. So here N is nothing but number of neutrons, right? N is number of neutrons. A is nothing but already we know mass number, and Z is nothing but atomic number, right? Once again you can see here. So N is nothing but number of neutrons, or N is nothing but number of neutrons, A is nothing but the mass number, and Z is nothing but what? Atomic number. So this is the formula. By using this one we can calculate the number of neutrons present in the different elements. So they will directly ask you like this: calculate the number of neutrons present in C612 C612 N740 like this. For 2 marks. If they ask like this, means what we need to do is very simple. So you go directly to the solution, and then one we can calculate. See, first you take, if they say A and B, means you take A1, that means A. In A we have this example. So if you understood, then okay. Otherwise, you once again go for like this. That means AZ. Directly, one we can imagine A is what? A is equal to 12. Z is nothing but what? 6. Right? Simple. Given. So what was given here? A value directly 12, and Z is nothing but what? 6. What we need to calculate? We need to calculate N value, right? So now just substitute these value in this equation. Definitely one you can calculate the number of neutrons present in this particular example. So what is A? 12, Z is nothing but 6. That means in 12 minus 6, 6. So that means what is the N? That means what is the N value of carbon here? 6. That means in carbon the number of neutrons are is equal to 6. Right? So very simple these problems are. There is one more problem. Right? So in this particular question, so we will solve this B. So now, so B is nothing but what? N714. Right? So this is our question. So now again, if you have understood, then no problem. Otherwise, you again go for like this A, Z. Now compare. Where there is a, what is the value given? You can say like this, given. So A is nothing but what here? 40. Okay, and what is Z? Z is nothing but 7. So now, what is our formula to calculate number of neutrons? N is equal to A minus Z. So now we know all the values. I mean A value as well as Z value. Just substitute. What is A value? 40, right? And what is Z value? 7. So that means the number of neutrons present in the nitrogen is nothing but 7, right? So likewise, one we can calculate by taking different examples. We will take another two examples. Right? So number 3, that means number 3, sodium Na, and whose value will be 11 and 23. Right? So again, what we need to do, the digit which is present upside of a element is nothing but what? Mass number. And the number which is present at the bottom or at the base is nothing but what? Atomic number. So now, sorry, A and Z. So given A is nothing but what? Directly when we can say 23. What about Z? Z is equal to nothing but 11. And 1 we need to calculate what? Number of neutrons. So now again, N is equal to A minus Z. So A is how much? 23 minus 11. How much it is? I mean, 1, 12, right? So 2 and 1, 12. So that means here the number of neutrons are nothing but 12. Right? If any mistake is there, please do remind me, right? So now 23 minus 11, there is a 12. So likewise, one we can calculate. I will give some only one example for you as an assignment. You just do it and calculate it and then send me, right? Send. So for assignment, see CL 1735.5. If you want, you can copy it down and then after video you send it to me, right? You solve this and send it to me, right? So these are the some problems. You can get many more problems. You just search in your books and calculate the number of neutrons in different elements. You can see many examples, right? So if you want, you can go into your book, or you will get more number of problems like this, right? So next is how to calculate molecular mass. So this is also very important for Pu first. So molecular mass. So that means the total number of elements present in the molecule we have to calculate. Say for example, we will just see one example of this CH4. So what is molecular mass of this methane? If they ask means what we need to do, how to calculate. So if they ask for carbon, definitely we can say 12. If they ask for hydrogen, one we can say 1. But what they are asking, the total molecule, mass of total molecule, that means molecular mass. The molecule is what? CH4. So that here, see how to solve, these type of problems. See, there is a CH4. Right. First, you just check how many number of carbon and how many number of hydrogens are present. So how many carbons? One carbon. So total means one we need to add them, right? So how many hydrogens? 4 hydrogens. See, there is only one carbon, so that's why I took only one. In case of carbon, plus how many hydrogens? 4 hydrogens. So thus I took 4 into hydrogens. Right? 4 hydrogens, 1 carbon. In this total molecule, what we can observe here is there is only 1 carbon and there are 4 hydrogens. Now, so 1 into what is the molecular mass of carbon? So that's why I said you please at least you try to remember till calcium, right? So this is very important for you. So if you molecular mass as well as atomic number, you need to remember these 2 points, right? So carbon, if you see, you can check it. If you know, then good. If you don't know, please go and check. So carbon molecular mass is 12. So thus 12 plus 4 into what is the molecular mass of hydrogen? Always it will be 1. 12 into 1, 12 plus 4 into 1, 4. 12 plus 4, 16. So molecular mass of CH4 is 16. So that means now I can define you that what is molecular mass means the total number of elements present in the given compound. We have to calculate their molecular mass by adding, right? So total number, it may be see the in molecule the number of elements may extend up to 4 or 5, right? So in case we have to add up all the elements present in the given compound whatever it may be, right? So what we need to do, we need to calculate each and every element with their molecular mass. So that's why please, this is the one, just one problem. So for tomorrow's class, if you want to know what is the molecular mass correctly, then please till calcium you just remember all the atomic number as well as mass number. Then the class will be very easy for you. So this is all about today's class. In the next class, we will just discuss the further part of, by taking some more examples, we will calculate the molecular mass of different atoms or molecules. Right? Thank you.